Alright, I'll be starting very soon here. Just give me just a little bit here. Alright, everything works. Awesome. Today's video is going to be on an even deeper look at storm chasing and storm spotting. You may notice that I've finally changed the colors that I use, though I do plan to keep the yellow and green for outbreak slides. So let's jump right in. What will be covered here? Storm spotting and storm chasing, of course, plus the differences they have, even though chasers are indeed spotters. Storm features will be covered here, along with detailed explanations and examples. There will be details on the dangers of chasing, as well as explanations on how to avoid being risky and therefore life-threatening. A brief reintroduction of different Supercell modes, that's what SC stands for, will be in this presentation, along with detailed explanations of storm properties, with notes for including tornado red flags and tornado strength indicators. Please note that near all of the following information will be coming from Skip Talbot. All pictures except for two in this slide are from his videos on YouTube. Notes here. Please always report to the NWS what you see. Do not report what you think is going on, especially if something is behind trees or behind houses. You can assume, however, that persistent funnels are indeed weak tornadoes, as usually, especially as you look further back in time at tornado outbreaks and how they're recorded, persistent funnels are often what indicate an EF1s to EF2s and below. Please never wait for touchdown. Report funnels and rotations, whether you are chasing or whether you are spotting, it does not matter. The current theory is our tornadoes form ground up, which means that the touchdown has already technically occurred and you're just now waiting for the condensation funnel to show the true tornado. Let's jump right into it. Spotting versus chasing. Spotting is, of course, usually done from home. Chasers are indeed spotters, like I said. However, they go after the storm, of course, hence the term chasers. Spotting usually includes much more radar checking and home or local news checking rather than anything else. Spotting can, especially from home, can actually be more dangerous than chasing, as this brings on to the next point, you are unable to move out of the path at home. Key note here is that both spotters and chasers need to pay close attention to tornado warnings. The polygon of the warning is placed so that the tornado is always in the smack middle of the. You can fold the polygon in half, and that middle crease there would be where the tornado should be, and where the track should go as well. Again, this part where it can actually be more dangerous than chasing leads on to the next spot. You are restricted to one area. The only place that you can go if you are spotting just at home is your basement. That does not mean you are out of risk. Of course, basements are indeed the safest spot to go during a tornado, but of course, the best possible outcome would be that the tornado just simply doesn't happen at all. Because you are spotting at home, you will likely be impacted by rain, possible hail, possible hail and straight line winds, possibly even a tornado warning, and at worst, if you live in a bigger populace, an emergency. But again, please remember that emergencies are restricted only for tornadoes moving into large populaces, which is thankfully not common. Spotting versus chasing now. Chasing is much more dynamic and hands-on. As the term chasers implies, these people drive towards the storm, and is usually done for research and helping the NWS, in fact Spotter Network, along with the NWS hotline, email, and online reporting are available for everyone. A note here is that Spotter Network does require its own training from its own website, which is a little off, but I digress. However, storm tracing does not have to be done for research and to help the NWS. It can simply be done as a hobby or even as a company. These tracer companies, usually tour companies, are. I would be surprised if there is a tracer company that is not organized by tracers who have had multiple decades of experience. Tracers will be feature checking the storm a lot more rather than radar checking. And of course, tracing does carry some inherent risk, but is risky only without awareness. Situational awareness. You will hear those two words a lot. They are the gold standard for tracing. Despite what you may think, tracers do not want to go into soybean fields or cornfields or anything like that to try and get better look at a storm. They are restricted to roads, preferably paved of course, and that's because gravel and dirt roads are unreliable both when driving on them and particularly on a map. Because they are loose, they flood extremely easily and they are not reliable to travel on because they may abruptly end even though a map or a GPS shows that it keeps on going. Or worst case scenario, you have that as an escape route and it's not even there at all. Lastly, however, this does apply for both spotters and tracers. There is no official organization for tracers and spotters. We are both indeed certified by the NWS, however, there's no organization to truly join. Therefore, all tracers and spotters are essentially amateurs, no matter how much experience you may have. Of course, the more experience you do have, you are technically a professional at that point. However, since there's no organization that truly states that you have this experience, you're still an amateur. A quick overview of a storm here. This is a more advanced diagram here. However, this model is indeed flawed in a few ways. And on top of this, things that I've said in previous slides are also flawed. However, the idea of pointing out flaws in a storm diagram and what I've said is not with the intention to say that the diagram is completely flat out wrong, because it's not. Rather, some elements are just simplified or not included in the diagram here to not make it overly complex or too hard to read. Of course, the point is with any diagram so you could visibly tell what's going on without having to squint and see if what goes to what. And the point here with this overview is to expand on the diagram or change what it examples to have a more accurate interpretation. Some examples of this are that the wall cloud is not and should not ever be a concrete indicator, and again, should not be your main source for indicating a tornado. The RFD is a little wrong here. It almost looks like it's forming shear over the flanking line and is a byproduct of the updraft, which it's not. It is usually around the cloud level base, although this is harder to depict when you also have words and some arrows here as well. The inflow jet shown in yellow here is likely the ghost train, and we will get onto that. On top of that, there is also different ways a storm is fueled. This one is indeed surface-based, and there's also elevated, where that an elevated level of air is stable, and then the inflow starts above that. So the stable air kind of acts as the ground. The features of a supercell. For note, those words in bold are not part of widespread knowledge, but definitely should be and definitely deserve to be. Knowing these will help out immensely both literally in the field when you're chasing, and of course, just at home when spotting. I will not list them off here to save a little bit of time, but I'll go off in the order that I've listed them here. First off is the updraft and its base. The updraft base is in bold here, as you should know what it means and what it is. The updraft is the tornado, of course, despite it being fueled by an offshoot or byproduct of the rear flank downdraft or RFD. The updraft base, essentially, is the place where the updraft is at the cloud base, given it's the base of the updraft. This does indeed evolve as the storm intensifies and evolves itself, seen here at the on the right-hand side pictures. It starts off smaller, then it bulges out, and then it curves, forming a horseshoe. Speaking of horseshoe, this, not a wall cloud, should be and is the main identifier of a tornado, and should be the main identifier of a tornado for you, whether spotting or chasing. The horseshoe generously acts also as a guide to tornado location, as it should be at the northern end. In this example at the top right, we are looking south, and from the other side, again, this is looking south, so this is actually the northern end of the horseshoe. I keep on wanting to say hook, although it is a hook. The horseshoe is actually the front part of the hook in radar, seen here in this previous slide. The horseshoe will generously show up with any supercell mode, and is especially helpful for high precipitation cells or HP cells, as when you're looking for a wall cloud, the wall cloud will be obscured by rain. The horseshoe is probably the single most important feature of a storm. However, please do not try and focus just looking for the horseshoe, as there are other identifiers you need to look for. Tunnel visioning is one of the worst things you can possibly do, as it can lead to a loss of situational awareness. Some examples are definitely shown here, and in this example here in the upper middle, this pink circle is to show the RFD clear slot, which will be talked about. The bottom right indicates how a wall cloud should indeed not be your main indicator that a tornado is about to form, as the horseshoe is seen here and the tornado is at the northern end. As you can see here, high precipitation supercell with the horseshoe. This is key because you cannot see the tornado. And an excellent example is the 2013 El Reno tornado. In fact, this updraft base is so powerful that it actually forms more of a horse hoof rather than a horseshoe itself. That's just how powerful this storm was. And also, the horseshoe is not just one per supercell. With cyclic supercells, the horseshoe will show up with each tornado if there's two at once. Moving on from the horseshoe, we have the rain-free base, or RFB. This is opposite cloud base to the direction of the storm, meaning that this is the southern or southwestern cloud base, indicated with the pink circle. It is also usually directly after the tornado. However, with different supercell modes come different rain-free bases. Near the entire base may be rain-free on low precipitation cells, is because there's little to no precipitation. However, on the opposite, on high precipitation supercells, the rain-free base may not exist, or will likely be smaller than normal. The picture here is the last picture that is not from Skip Talbot's videos. The other one that was not from Skip Talbot's videos was the overview of a storm. Seen here, it is the idealized view of a classic supercell, so you can see where the precipitation-free base would be on a classic supercell, and also a miniature. A miniature supercell is just a small classic. Allow me to take a drink here. Onto a triple feature here, the inflow notch, and the ghost train. The inflow helps feed the storm, seen here at this top right picture. The inflow notch is what creates the hook-like shape on radar, and is usually a very good indicator of a tornado on radar. Next up is the ghost train. This is not the rear flank downdraft, or RFD again, but rather is a rear inflow jet instead. This is seen here at the middle top picture, and is also seen here at the bottom two pictures at ground level. The ghost train is a very powerful, narrow wind band that feeds the tornado and is again created by the RFD. The risk of injury is very high if you encounter this, inside of a car or not. This can flip a car over and will likely flatten you to the ground if you get out of your car in this. This is definitely nothing to sneeze at, as we're talking straight line winds here, usually possibly more than 100 miles per hour. Up next is the RFD and its clear slot. The clear slot is always one of the most complicated things to explain, as a lot of the time it's not very well clearly shown, and on Google it is usually explained as the rain-free base when it is not, even though it is technically, yes, part of that. However, it's still not the RFB. Sorry, the rain-free base RFB. Yeah. But the clear slot is usually on the opposite side of the apex of the horseshoe, and this is seen here with this bright blue line. Shown one arrow to show the apex of the horseshoe, and the other to show where the RFD would likely appear on surface level if you're looking at it when you're chasing. On top of this, there are two types of the downdraft in nearly all storms, and definitely two types of downdraft when you're dealing with the supercell. This is the rear flank downdraft, RFD once more, and the forward flank downdraft, FFD. The FFD is indeed very rainy and is shown here, and may actually feed into the notch, though it usually may not do this. Again, the FFD is extremely rainy, and if there is a tail cloud, which is part of the wall cloud, it is pointed to by the tail cloud. The tail cloud points to the rain. Again, the RFD may be rainy, and it of course it's the rear flank downdraft. It wraps around the back end. The RFD may even circle around itself, seen here at the bottom picture, to form an anticyclonic tornado. This is labeled by Skip Talbot as an AT. On to the worst, most dangerous part of the supercell, the bear's cage. The bear's cage is simply wispy bands of rotating precipitation. Keep in mind that rotation will almost always appear to be left to right travel of these rain bands. The rotation will never look very tight, as the supercell and the rotating part of it takes up a very wide part of the sky. The bear's cage will envelop the tornado and is again the most dangerous part of the supercell. Do not go into the bear's cage, because the rain bands are the cage and the tornado is the bear. Especially with a high precipitation supercell, you do not know where the bear is. Even if you can see the horseshoe, that does not necessarily mean the tornado is at the northern end. Yes, I said that the horseshoe is indeed a very good indicator. However, this is, let's say, 90% of the time, not 100%. Nothing is truly guaranteed with weather, because it's Mother Nature. Mother Nature doesn't like being predictable. This top right picture is from the 2013 El Reno tornado, and very generously, Skip Talbot has shown that the bear's cage has actually become a tornado in this case, and that is because the tornado grew to 2.6 miles wide. 3 chaser groups, two of those groups unfortunately perished, were caught out by how wide this twister was, as they did not think that the bear's cage was the tornado. This is not to say that they didn't have situational awareness. Again, here at the bottom right, an excellent example of the bear's cage and then the bear. The left-hand side pictures from this main one at the bottom right indicates satellite tornadoes. Satellite tornadoes will almost always and do have the trend of traveling around the perimeter of the bear's cage, as the cage can be drawn in a relatively perfect circle. So again, satellite tornadoes can be more visible, and usually are since they're out of the rain. However, may not be the main tornado, and usually aren't, given that that is a satellite tornado. This is indeed very hard to tell when you're chasing in the moment, because again, everything is rain wrapped because of the cage. Aside from the bear's cage, we also have the tail cloud and beaver's tail. These are simply moist air condensation clouds, and especially in this bottom right picture, can definitely appear to be ground reaching from certain angles. However, they do not reach the ground. The tail cloud and beaver's tail can indeed form inside of the inflow notch, and is therefore usually not rainy. And of course, like I said before, the tail cloud will point towards the precipitation or the FFD. Not that much to go on here. One of the first things you are likely to see is going to be the whale's mouth and whale's teeth. This is immediately after your shelf cloud and is simply the turbulent gust front wake. Whale's teeth are simply scuds that form from a likely very ragged shelf cloud. Seen here at the bottom right, Skip Talbot has generously provided a dark blue outline for the gust front, but this also shows that the storm itself will outline the gust front by itself with a light green-blue in front of the storm. This is probably one of the first things you are going to see particularly if you're spotting at home and are in the path, of course. Next up here, we have storm properties and supercell modes. There are 4 modes: low precipitation, high precipitation, classic, and miniature. Now, the usage of the word mode is because supercells can change types if it is available to them, and they can change types multiple times. However, this kind of multi-change does not usually happen. The properties we will talk about here are the types of flow-based storms, height-based storms, tornado strength, and lastly, tornado red flags. A pattern, if you remember the 2018 December Illinois outbreak, and if you don't, that's perfectly fine, but this is a common, as seen here, cold core pattern tornado system, and is what caused the December 2018 Illinois outbreak. The main focus that I do want to show here is supercell variability, where Skip Talbot has generously also provided a circle indicating the bear's cage. Note how varied supercells look on radar. The middle one and the right are both high precipitation. To the left of that is a classic. However, there's also another classic here, below the 2 high precipitations. And of course, to the left, we also have a low precipitation. Note how this leftmost one is your true classic Supercell look, and this smaller one could be classified as a miniature. So we talked about flow-based and height-based. There are two types of flow-based storm, inflow-based and outflow-based. There is no difference in the way that a storm will act with whether it is inflow or outflow based. This is very simple. With inflow, the tail cloud points towards the rain and condensation, usually along an inflow jet of some sort, or where the inflow is coming from, so in the notch. And with outflow, the tail points away from the rain, and the same principle as inflow, so along some sort of inflow jet. So, and as well as that, we also have height based. There are two types of this as well. There is surface based and elevated based. Surface based, the stable layer is the ground, hence the term surface, and makes up so many supercells. It's what you will almost always look at. Elevated based are rarer, and that's because you need a cool, stable layer, shown here by Skip Talbot. And as you can see, these are extremely photogenic, as they form lenticulars on the tower itself, which is very, very cool looking. A little scarier looking, but still very, very cool. Storm properties. This will include the cyclic cycle as well as types. There are three types. There's linear, seen here, where you have your big updraft space, and this is a shelf cloud here. Your quasi-linear convective system, shown here at the bottom left, and both of these are usually your bow echoes, your squalls, and your derechos. And of course, you just have your supercell, the third type. And seen here in a clockwise motion are the steps that a cyclic supercell takes to form a new tornado. So we're going to label it out, or describe it though. The horseshoe, as you can see, straightens as it dies off, and the new updraft base forms. As the new updraft base forms, you see how it takes on the horseshoe shape once more. And then your RFD is also created as well. The third step is that simply the tornado forms. And then after that, it will either recycle the tornado slightly or recycle entirely, so the old base dies and the new base forms again, therefore going back all the way to step 1. Not too hard. Apologies, checking something here. Okay, we are good. One of the last things here, tornado strength indicators. This includes vorticity noodles, which I'll still call funnels, as well as normal vorticity funnels. And there are two types of these that I'm going to label. There are horizontal vorticity funnels, rather actually vertical, my mistake. And those would indicate that a wedge is forming, and that's because the true condensation has not formed yet. The true condensation funnel is not clear yet, so a lot of small funnels are directly below a very deep lowering of the base, which is part of the wedge. And then you have your odd angle vorticity funnels that would be your horizontal, and that is the one pictured here. These funnels, called vorticity noodles by some and by Skip Talbot, indicate an extremely strong updraft and extremely strong wind shear as this is pulling them to be more horizontal. A very good indicator of tornado strength is that the entirety of the bear's cage becomes a tornado. However, this is definitely more in the case of a telling how wide a tornado is rather than strong. Again, this is seen here, an example from the 2013 Reno tornado. Again, like I said, 3 groups of chasers, 2 of which unfortunately passed away, were caught out by how wide the tornado was. Of course, when the bear's cage becomes a tornado, this is even more hazardous than normal. Lastly here, your tornado red flags. This is stuff that will precede tornado genesis. These things will happen before a tornado touches down and forms. First is rapid left to right rain. Again, rotation is seldom tight and over a very small space. The supercell is very large, and the rotation is therefore large as well. Left to right rain is exactly what the bear's cage is, and is also, like I said before, rotation will look like. Secondly, the sudden inflow surge, or possibly convergence. Seen here by Skip Talbot, an example of a May 2019 incident where a storm chaser group was caught unawares and indeed make some mistakes. The sudden inflow surge think of it as the storm's deep breath, the final calm before the ultimate storm. Last but not least is a positive CG lightning barrage, or a positive cloud to ground strike lightning barrage. It is not really known why so much cloud to ground lightning, specifically that's positively charged, occurs before the tornado. But after the tornado forms, it will become silent or switch polarity, almost as if the storm is admiring its work. A reminder that positive charge lightning is more powerful than negative charge, of course. Sorry about that. The bolt is smoother and thicker, and the thunder also has the same characteristics, where it's just one big boom. Skip Talbot describes it almost like a mortar shell. That's fired off. Also, convergence may not appear on radar at all, but when it does, this is what it may look like on relative wind tracking, relative wind velocity. As you can see, the beam is actually scanning up this way, so more north-northeast. However, if you see here, this line is not parallel to the little pixels from the radar beam. This can indeed mean that this is in fact not the tornado, and the tornado is pointed out with the pink circle. This right here, where the velocity, where there's a couplet velocity that is parallel with the radar sweep, is where the tornado is, and this is where the convergence is. Skip Talbot also made a big circle here that indicates where the convergence is, and this is where your jets are. That's why this is so broad. And it's also seen here where that convergence, the convergence changes, and this is the line. The lines here are how the radar picked it up, and over here, more towards the bottom in a much darker blue, is how the tornado got picked up. So you can see how different that is, and how the convergence actually goes into those lines as well. That right there is the sudden inflow surge. This is the last slide here, and this is the dangers of chasing and how to be safe. The dangers obviously include the bear's cage, plus the forward flank downdraft because it will likely have a hail core. On top of that, very severe rain. The ghost train is also very dangerous. Tunnel vision is extremely dangerous, and chasers should never only radar check. The loss of situational awareness is particularly dangerous because this is what allows chasers to be safe. Again, situational awareness cannot be stressed enough. Awareness of features is what allows chasers to be safe even at distances that appear to be insane, such as this twister right here. This picture is part of a video that I was obviously able to get the GIF of, although I would love it if I did, from the December 2018 Illinois outbreak, where that these chasers were closer than 200 meters to this tornado. When listening to this person, when listening to the video, you can hear how he's pointing out exactly where the tornado is, as well as the ghost train. He's pointing out where there's a possible satellite tornado, and it's also pointing out where he can't go in the hail core. Note how he also knows that his escape route is immediately back the way he came, as this leads directly away from the tornado and all dangers. So this brings us on to safe chasing. Safe chasing includes knowledge and communication of features. Please do not chase alone, just like you should never spot alone. Safe chasing also includes situational awareness. Again, the two magic words, situational awareness, is the most important thing you will have when you are chasing and spotting. You need to have multiple escape routes, not just one, and they need to do the following: lead directly away from and do not cross tornadic regions of a storm. Specifically, lead directly away from any hazards. Escape routes should always use a major road network, so paved roads and therefore likely highways, with reliable and known conditions. Escape routes should always end in a safe location, not just clean air. Clean air would be east of a tornado, and that is not safe, as a tornado can change paths. You are still in the line of the tornado. Of course, safety can never be stressed enough during a chase, and the 2013 El Reno tornado is a example of that. If you watch a certain video that I have not shown here, what I do remember from it is that this person had all of the GPS locations of the chasers, and there were green dots moving around in real time. As the tornado forms and widens, all of the chasers suddenly become chased by this 2.6-mile wide monster, which is something that never happens. On top of that, probably one of the most haunting videos you could ever see is from a chaser who almost got caught and died from the 13 El Reno tornado. And he was directly with a father-son team who did get caught out and did unfortunately lose their lives. But both of them notice at the same time that they are in danger. And as their vehicles are traveling forward, he describes that he had his, this isn't a 1910s vehicle, this is a 2010 modern car, and he has his pedal to the metal of his vehicle, and he's only going 40 miles per hour. That's how intense the El Reno tornado was. And one of the most haunting thing is that you see in his rearview mirror how the father-son team's headlights slowly become smaller and smaller and fade away. They were right behind him, and then they weren't. Again, it's one of the worst things I've seen. But again, this is not to say that they were lacking situational awareness. They definitely thought that they could make it out in time, and in real time, without here, let's go back. Without this indicator that Skip Talbot made for us, how would we know where that tornado is? Now, think of all the storm chasers that were living in the moments during that. They didn't know where the tornado was either. This was on top of the fact that the 13 El Reno's funnel was only 200 meters across, and so it didn't even come close to showing its 2.6-mile wide girth and just how horrible this monster truly is. This is the very last slide here that has nothing to do with any of the stuff I've talked about. Simply going over what I'm working on. I'm going to be suspending streaming for now because I am starting work on Monday, August 16th. So I'm working on work, go figure, and also uploading these videos on YouTube. This one is going to be my first one. So thank you guys so much for going all the way to the end of this. I appreciate that so much. And I will see you guys next time. Until then, goodbye.